So there's another thing I want to show you to help you in terms of factoring. But in order to do this, you have to be able to completely list your factors for your lead coefficient and for your constant. So the factors for 4 are 1 and 4 and 2 and 2, right? And the factors for 7 are just 1 and 7. You don't really have a choice there. Now, was there a common factor with all these terms up here? No. Now there's a reason why I'm circling the factor pair of 2 and 2. What do you guys remember? Well, first you see that these guys have a common factor of 2, right? Here's the trick. If you have a factor pair that has a common factor other than 1, see if that common factor goes into the middle term. If it goes into the middle term, use that combination. If it doesn't go into the middle term, you can't use that combination. Okay? So does 2 go into 12?
Yes.
Then whenever I factor this, I'm going to start with using 2 and 2. So 2x and 2x. What about the signs here? What do you know?
Positive.
You have to multiply, get a -7, so 1 positive, 1 negative. Now, where do you think you're going to put the factors of 1 and 7?
7's going to go with the positive.
7 should go with the positive, right? And the 1 goes here? Let's check this to make sure. What do you get here in the middle?
14.
Plus 14x, what's on the outside?
Negative 2x.
Minus 2x, so there's your positive 12x. Questions about that guy? Does it make you happy? Let's try another one. All right. Let's see. How about 9x squared minus 27x plus 8? Is there a common factor for all 3 terms here? No. So what I want you guys to do is I want you to list the factor pairs for the lead coefficient and for the constant. So what are the numbers you would use for 9? 1 and 9 or 3 times 3. What about for 8? 1 and 8 or 2 times 4. Okay. Are there any factor pairs that have a common factor? 3 and 3 have a common factor of what? Does 3 go into the middle term?
Yes.
So that means I should probably use this combination when I'm factoring. But also notice over here I've got 2 and 4. What's their common factor?
2.
Their common factor is 2. Does 2 go into the middle term of 27? No. So what that tells me is that I can never use 2 and 4. I can't use that guy. So let's see what we have here. If I'm telling you that we should use the 3 and 3, so that means I should break this down as 3x and 3x. What do you know about your signs?
1 negative, positive.
You have to multiply to get a positive 8. Therefore, the signs must be the same. Right? Now I said that we can't use 2 and 4, so that means we have to use 1 and 8. Where can I put these guys? It doesn't matter, does it? Because, I mean, it doesn't matter where I put the 8, there's never a contradiction for that guy. So 3x minus 1, 3x minus 8. Does this check out?
Yes.
minus 3x in the middle. On the outside you get what? Negative 24x, so there's your negative 27x. Everything checks out. Are there any questions about that guy? All right. Let's try to put some of these guys, these techniques that we were talking about, let's try to put them all together, and let's try this problem. We have 6x squared minus 17x plus 12. What's the first thing you always do when you're factoring?
Look for the common denominator.
Always look for the greatest common factor.
Common factor, I'm sorry.
Is there anything that goes into all three of these terms?
No.
No. Well, let's look at those factor pairs that make up the lead coefficient and the constant term. What are the factors for 6?
1 and 6, 3 and 2.
1 and 6 or 2 and 3. Do we have a factor pair that has a common factor other than 1? No, so I don't get any help from his factors just yet. What are the factors for 12?
4 and 6.
No, don't jump around on me. 1 and 12, 2 and 6, 3 and 4. Are there any factor pairs that have a common factor? What was that? 2 and 3.
2 and 6.
2 and 6 have a common factor of 2. Does 2 go into 17? No, so that means I will never ever be able to use that guy. Okay. Well, see, we've eliminated something from the possibilities. There's still a lot of stuff to try. Now, a general rule of thumb is to try the smallest factors first, and then then use the larger ones if you need to. So if I'm doing this on my own, and I don't know exactly where I'm supposed to go, and I'm just kind of guessing and checking here, I'm going to try to use the 2 and the 3 first over here. So that's 2x and 3x. What do you know about your signs?
Both negatives.
Both negative, because you have to multiply to get a positive 12, but you need negatives when you're done.
Right.
Now let's think about this. If I try to use the 1 and the 12, can the 12 go with 2? No. Can the 12 go with 3? So that's not going to make any sense to try to use that one right now. What about 3 and 4?
Yeah, you put the 3 with the 2.
3.
Right, I cannot put the 3 with the 3. That would give me a common factor, it's a contradiction. So if I put the 3 here and the 4 here, does that work out?
3 times.
We get negative 9x,
That works.
negative 8x, and oh, there's my negative 17x. So number one, I used logic here to tell me that I'm not going to be able to use this combination because they'd have a common factor of 2, which meant that when I add them, that would end up being a multiple of 2, but the middle term is not a multiple of 2. 2 does not go into him. So that's why he was crossed out. Then I said, you know what, start with the smaller factors, so I start with 2 and 3 first.
Oh, okay, so you just keep going.
1 and 12 would have given me contradictions, so that would not work. 3 and 4 would only give me a contradiction if I put the 3 here. But by switching these guys around, 3 with the 2, 4 with the 3, I end up with the right answer. Now if this didn't work out, you would then try using 1 and 6 or some other combination.